Hi, thank you for inviting me as a guest speaker to the 6th International Conference on Computers, Management and Mathematical Sciences, for me in virtual India. My name is Alexander Pfeiffer and I'm going to represent our research topic Digital Agent Signatures and EIT Wallets for Human-Robot, Robot-Robot, Robot-Human interactions, and why we need to assign secure digital identities to our online assistants and bots. My research colleagues are Alessia Serrada from the University of Vaasa in Finland and Mark Bucceya from the University of Malta. Let me briefly introduce myself. I have a master's degree and a doctorate from the Vienna University of Economics and Business, a Master of Arts in Game and Media Studies from Danube University Krems, an executive MBA from the Alaska Pacific University, and I'm following a lifelong learning credo, so I'm currently approaching my second PhD, this time in the field of artificial intelligence at the University of Malta. I'm working full-time as a postdoc fellow with a Max Kade stipend at the MIT Educational Card in Boston, and I'm also a co-founder of two companies, the Picapipe GmbH, with which we won the Austrian Blockchain Awards in 2020 with the project Hot City, and I'm also co-founder of the Malta-based BNP Emerging Technologies Lab. So let's start to talk about our issue. And our issue has two players. On the one hand, us humans, and on the other hand, the robots. So as a human being, I can of course act on my behalf, but I can also act on behalf of the family that I represent. But of course, I can also work in a company. And as I am behind the curtain in a company and I sign something, as for example a member of the board or director, then it's always the company name itself, the limited company in the front line, that appears in the contracts and in the interaction processes with others. And in all those different fields, representing myself, representing my family, representing my company, we humans tend to make mistakes. Those mistakes can be done unintentionally. We all made typos in our emails when we reply quickly from the mobile phone. But those issues can be also caused by intention. When it is my intention to fraud the system, and it is my intention to manipulate data. And then even if we use the highest sophisticated databases, when the mistake itself comes from the human being as an operator, we have a big problem. On the other side, we have the robots, and as we know them also from science fiction movies and from shows and from events, they can be manifested actually in a body representing the artificial intelligence behind. So here, for example, we have Sophia, one of the most famous robot identities out there. And of course, there's more than one Sophia, because the AI itself is run on a cloud service. And of course, there can be hundreds of Sophias running around and all taking the information they need from the cloud, but then at the same time learning while interacting in the different countries. For example, Sophia is appearing. This time, for example, presenting the national AI strategy in Malta. And those AIs or robots, they can even tweet, but of course they do not need their body and they don't need their fingers and the keyboard to do such tweets. It's just the software doing this. And for Sophia, we don't really know it. It can be a marketing manager doing the tweets, pretending that it's Sophia tweeting and writing on Facebook with us, her fans. And those robots, they can also interact with human beings. Very famous show from Jimmy Fallon, The Tonight Show, and there's some great scenes that you can watch on YouTube, like when they met for the first time or another time and they're singing a song together. But even Sophia can appear in a movie as an actress, as a bot appearing in a series that we like and watch, like Sophia acts as Fiona in the show Silicon Valley. And then they can even interview us humans. So it's the other side. And here in this case, Sophia is asking Will Smith if he thinks that in the movie I, Robot, that the robots there are presented in the right way, so to say. And long before Sophia became famous, there was Phil, the robot, and there is a great video and a great interview with Phil, when the interviewer asked him if he, as an AI entity, thinks that robots are taking over the world. And Phil responded to the interviewer that, well, I see that you have two nice kids. Maybe he found the photos on Facebook. And I like you kids, I like how they act, and I like how you treat me here. So if we take over the world, I'll keep you warm and safe in my people zoo. Maybe this was a pre-scripted joke, I really don't know it, but I think it was a really great reaction, and it tells us that we have to treat our digital agents, our digital identities, the way we like to be treated ourselves. And then, of course, it's the robot to robot interaction. And just recently, this year, end of March, at the Web Summit, Phil met for the first time Sophia the robot, and their programmers and developers were next to them, and they were having this dialogue together. And again, we don't know if this was pre-scripted or if really happened live. But it's great to show that this robot to robot interactions will occur in the near future. But most of the time, when we speak about artificial intelligence and robots, we will not see it in the person of a robot, so to say, but it will be simply computer code running in your apps, running on the cloud, running on the piece of software you start and you operate. And of course, we all are interacting in our daily lives with such digital agents with AI. You all know Siri, you all know Alexa, and maybe you try to make some money on the stock exchanges, and there mostly everything is run by digital bots, especially when you look into the field of cryptocurrency trades. But even if you play computer games, the AIs that you encounter there playing FIFA soccer, for example, that's a digital bot playing a digital virtual soccer player against you. And this is also the way when we humans enter a digital world and appear as a digital avatar in our computer games. So this is, for example, me in an augmented reality game we made with Danube University Krems and Dr. Sewald. It's called The Magic Mirror. Or the head of center from the Center of Applied Game Studies, Natalie, in Minecraft. So we human beings can also enter a virtual world, a digital world, and have a digital representation there. And this is why I think that game studies, or when you look into media and computer game studies, truly helps you to understand the future of interaction between humans, robots, and robots to robots, and robots to humans. But of course, all these devices can nowadays have kind of an identity and interact with each other and with us humans. And this is what we call the Internet of Things. So there's this trend that kind of every device you own has a connection to internet, has an IP address assigned, creates information that might be useful for you as the user, or might be useful for the company that created such a device, so that they gain data and sell it, for example. And a huge problem that we have is the security problem of such devices. So most of those devices, even from like smaller companies, for example, when the company gets, in the worst case, bankrupt, but to still keep the device, then you cannot update the firmware, and then you have security leaks in your devices. But even if they come from well-known companies, it is not said that they come without any security leaks, as we've seen in many, many cases. And this is a comic that I like a lot, where we see all our digital devices trying to blackmail the user. For example, $20 in my PayPal account, and I only coffee without coffeeing, I would for sure pay those 20 bucks immediately to my coffee maker. And here we already see some issues in our daily news. So DDoS attacks through such devices that are unsecure in your internet, and then hackers use such devices to ping an internet address, and then therefore the amount of traffic to this address is huge, and then the website goes offline. So maybe your toaster already tried to DDoS some service from a company. And then we have this funny story, but I think that's really showing the point of the problem regarding the digital identity security measures related to this and so on, is when on the TV show someone ordered toy houses, and all those Amazon Echo devices were listening to Alexa, ordered this toy house with the number XYZ on Amazon, and then thousands of people that have where they as a user do not need to confirm it manually, ordered such toy houses, and then they had, of course, they had either had to send it back, or maybe they received this email saying you just ordered the toy house, and then they were able to click on cancel. And of course, a really huge problem, in my humble opinion and of many others, are smart meters installed in your homes. They need to have the highest standards of security, the highest standards of encryption and communication, for example, in this case with the energy providers. Because if we have either malfunctional software, doesn't matter if it's by accident or not, then they can cause huge problems like overloading the networks. Or if hackers take control over it, they can cause a blackout because they basically ask for more and more energy and power, and then the lines cut. And there is a paper from Princeton University describing especially this case, and saying that our next huge problem we have as a society are going to be the energy blackouts due to hackers and smart meters. So let's go back to the core topic of the talk, the human-robot, robot-human interactions, and the questions that we have to ask ourselves. So first of all, who acts in the name of whom? How can the identity be verified? Catchword, the chain of trust. And how can the performed activities be logged? So again, on the one hand, we have the human being, and on the other hand, we have the data of the human being. So the human being needs to have a kind of a digital identity. We need to know who is this human being, and for whom is this human being acting? Is it for, as said again, for him herself, for a company, for another person? And then we have all this data, and the data can be stored on a local hard disk, on a USB drive, or in the cloud. And what is this cloud? We all trust cloud services, but we all know that this data is not in our hands, and we have to trust the company operating the cloud service, that this data is secure, that this data has not been manipulated, that this data cannot be just taken away by hackers. So which kind of identities do we know? We all know the passports. We use it in many occasions, not only for traveling. So, and all those passports, of course, have some kind of a security implemented, like biometric chips. But of course, we also know that somehow and sometimes it's possible to fraud passports and to have fake identities, at least until the point of time someone catches you with that. Then we have the identities in social media. And we all know that identities in social media can be easily frauded. Maybe you know the website thispersondoesnotexist.com. And every time you click on refresh, you get another picture of a human being. And the last years, this improved so much that it's so hard to find the difference, that this is a generic picture created by an artificial intelligence. Now imagine that someone is taking those pictures, uploading it in the social media, giving those accounts a life. And if this person is doing this in a brilliant way, there is no chance for you, without being a detective, to find that this is not a real person with whom you talk to. And then even if we have this verified Twitter accounts, just some weeks ago we had this huge Twitter hack, and the hacker was able to tweet on behalf of many, many people that have these blue tick box next to the name. And I wondered that this was just like a one-day thing for us. We said, okay, Twitter was hacked, but next day everything is fine again. For me, this is really showing that digital identities through social media are such a huge issue, and that every one of us has to be aware and has to verify with whom you're actually communicating and whom you're telling what kind of thing about your life, or to whom you give which information. The same, of course, applies with emails. But just a side note, with emails, you always can look into the header and then find out that the email address has been manipulated and who is the true sender. But then it's maybe a lack of media literacy in most of the users, lack of, that they do not know how to look into the header of an email, for example. Then we have identities issued by banks. So for example, in Austria, there is a bank called the Erste Bank, and they have an identity service called S-Identity Service that you can use as your digital identity, of course, especially for interactions with the bank. But then, for example, if you open an online bank account, let's say with a bank called Revolut, and then they kind of take over your mobile phone, so you allow them in your app to use your camera in the mobile phone to even turn on your light there. And then you have to show live in a conversation your passport. They turn on the light. With that, they look into the security measures of your passport, etc., etc. In this case, you give access to functions of your mobile phone to a third party. This is something you always should think about if you really like to do it. And on the other hand, it's just some people working for a company that try to identify people on behalf of the client, the bank. So it's always difficult, and we talk about this in a minute, about this, who starts this chain of trust, with who is verifying your identity, and who is the first one verifying and giving you your digital identity. And for that, in the European Union, we have the EIDAS regulation, and this has been implemented by law in the year 2014, basically setting standards for digital identities within the European Union via the local trust centers, for example, the D-Trust in Germany, the Lux Trust in Luxembourg, the A-Trust in Austria. And then all those digital signatures, as we call them, they should be easily verifiable by other countries or within the country you act and you use it. And it's really working great within one country. So for example, in Austria, you get your digital signature, you can use it to sign PDFs. Nowadays, nearly everyone knows about it and accepts it, and you can use it as secure login. So 98% of all e-government or government tasks you can now do by e-government. And the 2%, it's by a decision that the Austrian government does not want those like 2% to be happen via the address signature. So for example, if you move from one place to another, you still need to speak with a government officer. And so if you read about those high score lists, which country has which percentage of e-government tasks applied, they are, sorry for this word, bullshit, because of course it's possible to do everything with the digital signatures, and on purpose it's maybe better not to have this by 100%. But anyway, with this EIDAS regulation, and that's the point, when you do cross-border interactions, so for example, I used the Austrian signature in Italy, and then they look at you like, what the fuck is this? because all those offices did not find a good way to peer-to-peer accept the different ways how they implemented the digital signatures. And the European Union knows that this is a huge problem. And this is why they are now starting the next initiative, which is the electronic ID. And now they want to set standards so that it's not developed by the local entities and the local providers, but they have to use the profiles and the standards actually set by the European Union, so that this peer-to-peer acceptance is easier. But by regulation, by law, this is also still based on the 2014 eIDAS regulation. And now let's come to the point about blockchain and smart contracts and digital identities and how we can assign this then to digital agents. And there is this term, it's called the self-sovereign identity. And the most famous approaches there are from the Sovereign Foundation. And they want to set standards to implement and to give the identity back to the people, so to say. Again, we have to think about who is the first one giving you that identity that you can later use. There's also a standard set by the W3C Foundation for digital identifiers. And I think this is a really great initiative. And as you see here, it's dated 1st of October 2020. So the newest version is actually 2 months old. And with that, you can work and create software solutions using decentralized digital identifiers. And one of these recently won the hackathon on the other blockchain. And there is this website where you can just play around with those digital identities. And you can set digital identities either in the classic sense as the eIDAS identities are doing it, or you can use it to trigger private keys. So for example, only the system itself knows the private key, not the entity who created the account. And the connection to the private key from the perspective of the user is with his own or her own digital identifier. And this digital identifier can actually be used to set higher security standards when in some years the computer power increases and increases and you need higher security standards for your private key in the network. Then you could use digital identifiers to basically create a new private key meeting those new standards. What we are currently trying is that we combine the digital identifiers from the W3C with W3C standards with the secure certificates from websites. So basically our claim is that if you have an email address from a domain, in our case from a university, then you can be at least sure to a certain part that this person acts on behalf of the university. But of course there could be, for example, on the other hand, a list on the university server, an encrypted list where you get access and you confirm that this person actually works at the university. Of course, again, if someone comes with a gun to the head of the officer creating this list, creating the identities, you can of course also fraud and manipulate the system, but it's going to be much harder. And for this purpose, regarding identities on the one hand, and using utility tokens, so blockchain-based assets that are not tradable, that fulfill a particular purpose, and that are owned by the person, by the entity that is allowed to fulfill a task or to have access to something. And we as the research group, we call it the electronic identity wallet. So basically, what type of blockchain-based assets exists, and there is a huge discussion because there's no common wording between all of us. So to make it short, 4 types that we suggest to talk about: cryptocurrencies, most famous one, Bitcoin, Litecoin, with the purpose to store value or to trade value or to purchase something. We have the tradable network maintenance utility tokens they can be, of course, also used as cryptocurrencies like Ador, like the most famous one, Ethereum. But with those, you maintain the network, you pay the fees for the networks so that they process, in most of the times, the utility tokens created on the platform, on the blockchain network. Then we have the tradable utility tokens. They can be tradable either just with the regulations or the rules set by the issuer of the token, or they can be freely tradable on the market, like we had with this ICO hype from 2017 to 18. But the type of tokens we're talking about, and I built most of my research on, we call it the non-tradable utility tokens. So our main purpose is that this token fulfills a particular purpose, giving you access to a service, representing ownership, etc., etc. But we make sure that those tokens cannot leave the account of the person owning it in a rightful way, that they cannot trade it besides the original purpose assigned to the token, and of course that they cannot trade it versus money or just send peer-to-peer to another account besides the one blockchain address it is supposed to stay with. And this is quite similar to wallets like the Exodus wallet, where we store the cryptocurrencies. But it's easy to imagine. Besides, so in your wallet that stores the cryptocurrencies from different networks, you store the utility tokens from the different created on the different networks, and each utility token represents another task. So here we have the utility tokens just above my head, the EIT wallet plus the blockchain wallet of the person XYZ. To that you have some identities assigned to that you as a user can always choose which kind of identity you use for which particular purpose. I had to move it on the top of that so that I don't cover it here with my body. And then we have these utility tokens attached, and most of my research projects deal with storing learning credentials on your identity wallet, and then it can be shared using using an identity of yours. But there you can also store health data, you can store concert tickets, or you can store the access to municipal services, like if you like to deposit waste. And then it's the multi-chain processing. So this EIT wallet is not only related to one particular blockchain network, which is truly important that it comes into life and that people use it, but it's capable, like this Exodus wallet I've shown you before, to handle different transactions from different blockchain systems. And then you can either just use the tokens you have and show that you are the owner of the token. You show it, you get access. Or to get access, for example, for one-time thing like a concert ticket or for a voucher for a coffee or whatever, then the token could also be sent to another account, so it is burned and you can no longer have access and use it. And now with digital agents attached to it, I like to give you a very simple task, is that I have a digital agent and I want this digital agent to look up if I have to pay tax. And I set the parameters and I allow this digital agent to pay tax up to 5,000 euros. So basically I would use my digital identity as a person. Then there is a blockchain-based asset which stores what the digital agent is doing on my behalf. For example, with the encrypted message on it, or it's just messages sent from the account associated with the digital agent to itself, but of course with the timestamp, etc. We know when some task has been performed, and my digital agent can autonomously look every quarter of a year if I have to pay tax and pay it, using a sub-signature of my digital signature to prove that it acts on my behalf. And as everything is encrypted, only I have access to the information, and in this case the local tax authorities, and all others would just see blockchain-based transactions and IDs, but they would not know why those transactions have occurred. In the educational sector, This would mean, for example, that there was a thesis defensio and the 3 professors signed that the student passed with an A grade. Now the whole process starts and it takes a full month until the person gets his or her certificate. We can now use digital agents that the dean and others sign automatically, but of course, randomly human beings have to look into the transactions, and this would speed up immediately if a person can call him or herself master. And very shortly, this is my research project at MIT. We created a game-based learning and assessment tool so that if the student passes, so first the student learns about a particular topic and then he or she passes an exam and automatically gets the grade. And we also send additional information, for example, to the teacher so that he or she becomes a better teacher. We did quite of the same with an e-learning and assessment tool, combining it with a well-known learning management system, and then we tried it with virtual exams via Zoom and trying to prototype this process of the professors signing it and other authorities co-signing it automatically. And here again, I like to show you how the chain of trust works, and that you can easily take from education to any other purpose and any other field, because it would be always more or less quite the same. We have an authority like the European Union assigning the possibility to a government, to a country, to give out digital signatures. In Austria, we have a federal system, so we have counties and within the country. So for example, it's Austria, but the county of Vienna. And then the county of Vienna gives a digital signature and the permission to then again give signatures and identities to their teachers. So the school gives the identity to the teacher. The teacher gives the identity to the enrolled students. This is then basically all stored on a particular blockchain address per person per entity, which then can store, here in our case, a part of an exam, the diploma, etc., etc. You can share all those single grade, the diploma, with third parties, and for that you generate shared keys. This is how it would look like on blockchain. It's a very simple demonstrator here. So basically we have our account from the university that confirms that for this paper, in this case, the university is using this blockchain account, and then the blockchain account is sending a message to itself publicly, just with the blockchain addresses of the enrolled students, for example. This is then all signed digitally using the Austrian A-Trust signature, so that we have this second circle of proof. It's not only a tweet, you can also put it on the university website. And if you sign it digitally, you also have it on the government or e-government websites, where you can look into if this is valid or if it has been frauded. Then of course we can work with encrypted or not encrypted, that means public messages with the information on it. Each transfer generates on blockchain a unique ID. Each utility token used, of course, has, when it's registered, a unique ID on blockchain. You can either pre-generate a certain amount of one token, or each time you generate a singleton token. This is basically a matter of how your use case looks like. And here in this case, it's shown how this shared key would look like. And then you can, for example, when you apply for a job, use this shared key to send it to your boss. And then he can verify, or she can verify, that this is actually a real diploma. We are working with a blockchain called Ador from Jello Reader. But of course, you can work with any kind of blockchain that fulfills the purpose and the need for your project. So for robot-human interaction again, you have the human person with a blockchain-based wallet and with a digital identity. You create a digital wallet, blockchain-based wallet, for each of your digital identities, which is linked to your wallet, for example, with an initial transaction. Each digital agent automatically gets a sub-signature, which is linked to your original signature, and which is the proof that you allowed this agent to work on your behalf. Now this agent can either directly interact with other humans, with other websites, with other robots, and on the other side we have the partner, the company, the person, etc., which also registered his or her digital agents on blockchain using sub-signature, using unique blockchain addresses, storing utility tokens on these addresses. And then of course we see the transfer of the tokens. We have the messages attached to it. With some of the tokens you can even use the token property field to describe which kind of token this represents, etc., etc. And I showed you this identity wallet before, and now the digital agents kick in. And here you have the identity wallet of a person with all the signatures related to it. We have again all the kind of utility tokens, but for some of those tokens and for some of those processes, you also allow your digital agents. So for example, if you like to sell a concert ticket, you allow the digital agent to sell the concert ticket on your behalf. You want at least 50 euros for it. And digital agents puts this sale order on a platform for concert sales. And as the token is based on blockchain, it has been issued, for example, by the Austrian Ticket Agency. There is no more black market. There is no more dealing with overpriced tickets. This is quite similar if you play Ultimate Team on Pfeiffer soccer and you like to sell players, and in the first years it was chaos and a lot of fraud happened, and now the publisher of the game sets a minimum and a maximum price based on a certain algorithm, and the same could happen here with the tickets. So this could really secure most of the system we know and the way how we interact with our digital purchases and our digital keys to use services. What you should never forget is the ethical perspective, and this was an award-winning poster from Alessia and me on the European Conference on Artificial Intelligence, where we talked about the network of human and non-human agents on blockchain from a philosophical perspective. Especially Alessia talked about it because that's the expertise from Alessia. But it was a great experience, and this is something you should never forget, especially if you're coming from the tech side, that there is also a sociological side and a philosophical side and an ethical side with everything we do. So thank you very much for listening to the talk. We have another 8 minutes for questions. I'm really looking forward to discuss it with you. You find here my ResearchGate profile. It's Alexander_Pfeiffer. My email address is alex_pf@mit.edu. So of course you can always write me an email and to get in touch with me. And I go live now, and I look forward to speak with you directly.